There you go. So let's start off with a review problems. Some review problems. So number 1, say let f of x be equal to negative 3x squared plus 2x. Let's say simplify the difference quotient f of a plus h minus f of a, all of this divided by h. They usually give you a condition at the end that h is not 0, right? But for us, it's fine, right? We're just gonna simplify that expression. Number 2, let f of x be equal to 3x divided by 2x minus 3, and g of x is equal to x minus 4 divided by x minus 3 minus 1. Yeah. Evaluate f of g of 0. And number 3, let f of x be equal to 5x over 2x minus 1, and g of x say is equal to 3 over x plus 2. I want you to simplify f of g. Number 4, set let f of x be equal to 3x plus 2 over x minus 1. I want to find a formula for the inverse. Yeah. Number 5, say let f of x be a piecewise function, like this. So say it's negative x when x is less than or equal to negative 1, and it's 2 minus x squared whenever x is bigger than negative 1. I want you to sketch the graph of f of x. Number 6, say let f of t be equal to 3t minus 4 over t. I want you to find the net change and average rate of change from t equals negative 1 to t equals, say, positive 2. Number 7, this is more relevant to what we were doing earlier. Evaluate, say, sine of pi over 3 plus cosine of pi over 2 minus sine of pi over 3 times cosine of pi over 6. And one more. 8. Find a coterminal angle between 0 and 2 pi for the angle say theta equals to, put 17 pi over 3. We're gonna start off with these questions. These are like questions that I think we all have seen before, and we just want to be familiar with how do we like go solve them. Yes, there are some people that know these, but yet when it comes to a test, it's like they have issues, writing out the answer in a way that, we can understand it. And I told you that 3 people will be grading your final exam, and the way that they do it is that, yeah, let me finish. Yeah, so 3 people will be grading your exams, and they don't have like all of the time in the world, right? They have like 5 seconds per question, right? So they have to decide in that 5 seconds how much is it that you don't know. They put minus points, right? Once they get to 20 points, they stop grading your exam, they mark it, and they put it on the side, meaning that you are going to get a score below 80%. So when we get the results, we just get the results of those who passed, and those who failed, they just say that they got some score below 80, and they're trying to save time by not grading everything. If they get to a point where, say, you already lost 20 points and there's still more questions, I think they put it on the side, and they just say that you are not ready to move on to 195. You have to stay in a regular class for 190 and go through the entire semester, learning all of these little by little by little. Right? It will be exactly the same material, but it won't be rushed. It won't be one day and then the next day and then the next day. See, we meet for 3 hours every day. In a class, you meet for 1 hour and 15 minutes, right? Twice a week. So that's like 2 hours and 30 minutes, and we count that as 3 hours. But you're still missing 30 minutes. So 2 hours and 30 minutes per week. So it goes a lot slower. Yeah, you're learning the same material. Here, we are okay with the program like this one because this is material that you have seen before. This is something that you have an idea how to solve. You just have to put it together and see how does it make more sense, right? Before you continue on to, if 1 or 2 things here are clearing out, that's a good thing, right? That is what you need before getting into pre-calculus. In pre-calculus, things will clear out a little bit more, and then when you get to calculus, things will make more sense, right? You think things will just connect a little bit more. Huh? Yes, guys.
So you said 3 people will grade the final.
Mm-hmm.
Are you two gonna be one of those 3 people?
We don't have anything on it. Yeah.
I'm relate.
Yeah. So, and those people who are grading, right? One of them, well, there are 2 of them who are really really harsh. You make a mistake, a minus mistake is like you did a terrible thing. And what we're doing here is trying to tell you, if you make a mistake, you have to pay for that mistake. You have to be as clear as possible. There are students who know the answer. It is just that when it comes to making it clear that you know the answer, sometimes students take a route. They have the answer, and it's hard to find it. It's like just try to put it as clear as possible. Here is my answer, then, and then try.
So if somebody doesn't get above 80, right? Let's say somebody gets close to 80, but not above 80. So what's gonna happen to them? Like, when do they start taking the same class again?
They in the fall. So instead of taking 195, they will take 190 on the fall. The class start on August 27th. Yeah. And I'm telling you, all you have to do is push yourself a little bit more, do a little bit more, practice a little bit more, and make sure that the topics make more sense. If you're making a mistake somewhere, just try to rectify that. Yeah.
Is there going to be partial credit on the final?
Yeah. Some questions though, they have no partial credit. some questions is you get it right or wrong. If you get some of it wrong, I mean they will tell you, okay, the person just made some silly mistake, but that's not good enough, right? So we know this because in a regular semester, they send out a grading rubric for the department final. And in this grading rubric that they sent, they say, for this question here, no partial credit. For this question here, no partial credit. For this question here, no partial credit. So we are aware of how the grading, the rules that they go by. And we know this because, again, in the regular semester, classes that are before 6 p.m. take a department final, and the department final, right? Last semester they did a group grading where this person will grade the first 10 problems, the next person will grade the next 10 problems, and so on, right? And they gave us a grading rubric on how to grade, and for most of them they have partial credit, but some of them is like right or wrong. It's like if you don't know how to do it, they won't give you any partial credit. But
They look at your work too.
Mhm. Yeah, definitely. Yeah. Yes, Cassie?
If somebody gets, so everybody has to get above 80, right, in order to move to 195?
Mm-hmm.
Not less or not 80?
If 80 is fine, yeah. But
how about 79?
yeah, it's up to them. It depends on the mistakes that you make. So 2 years ago when we first taught it, right? There are several students who had between 75 and 80, and so they had to make a call whether they were missing fundamental understanding, or was it just silly mistakes that they were just doing. But they will be the ones making the call. But we don't know who got between 75 and 80. But they did give us a number of students who scored between 75 and 80, and they did this so that we are aware that, hey, maybe if students push themselves a little bit more, then they didn't have to make the call for you. It will be clear that you are ready to pass, right? But of course they're human beings, right? And then if you're close enough, I'm pretty sure that some can sympathize, right? Right. So let's start with number one, right? With number one. So you're given a function and you're asked to simplify the difference quotient. Like this. Let me just move this down. Ouch. There we go. Okay. So let's see. Simplify the difference quotient. Let me do it this way. What is f of a plus h? This will be negative 3 times a plus h squared plus 2 times a plus h. And we expand this out, and we're going to get negative 3 a squared plus, right, 2ah plus h squared plus 2a plus 2h, like this. We're going to expand this again. This will be negative 3a squared minus 6ah minus 3h squared plus 2a plus 2h, like this. And we have f of a, and f of a will equal to negative 3a squared plus 2a. When we put this in the formula, we're going to get f of a plus h minus f of a divided by h. And this is what we're going to get, right? So we're going to have negative 3a squared minus 6ah minus 3h squared plus 2a plus 2h, and minus, and I'm subtracting f of a, which is here. When I subtract it, the signs will change, right? So instead of having negative 3a squared, I'm going to have positive 3a squared minus 2a. And all of these is being divided by h. So what cancels on the numerator? Yeah, the 3a squared will cancel out, right? Yeah. And the 2a's will cancel out, right? And when we are dividing every single one of the numerator terms, right? The terms in the numerator by h. So in reality, we have this. We have negative 6ah divided by h minus 3h squared divided by h plus 2h divided by h, like this. And this simplifies to negative 6a minus 3h plus 2. And that will be my answer. notes.
And get them right on that table.
But you know, it's important, right? You're here, and yeah, you should take some notes. Yeah. It's a suggestion. It's not mandatory. It's a suggestion. Yeah. And it's nice when someone gives you a nice advice. It doesn't cost them anything. Right. So does it make sense for the first one? Question?
The first line, right? You did plus 2a plus 2h.
So.
Or you distributed it.
Yeah. So I have this right here. Right? I distributed that 2 from here. Yeah. You see the 2 is distributed this way. Right? So I get 2a plus 2h. Yeah. So the first thing is, I wanna know what f of a plus h is. I want to know what f of a is, and subtract the 2 of them on the numerator. Yeah. Yeah. Right. So let's move on to number 2. Yeah. For number 2. Right. So this is what we are asking. We are being asked in number 2. So you're given f of x and g of x, and you're asked to compute, right, f of g of 0. This will be f of, what is g of 0? G of 0 will be, yeah, 4. And what is f of 4? That will be 3 times 4, yeah, minus 3, right? So all of these will be 12 divided by 5. Yeah, and we can simplify that fraction, right? 12 over 5. So that will be our answer there, just 12 over 5. So for number 3, let me move this down again. Let me see. Yeah, for number 3, we're given f of x and g of x and are asked to simplify the composition f of g. So for this one, yeah, we're going to have f of g of x. This is just going to be f of g of x. And this is going to be f, and g of x is 3 divided by x plus 2. So this will be, so f of x is that 5 times x, where the input is no longer x, right? And then divided by 2 times x minus 1, where the input now is going to be 3 over x plus 2, and then 3 over x plus 2, and then minus 1 on the bottom. So the best thing that we can do here is that 1 on the bottom, we're going to multiply this by x plus 2 over x plus 2. By doing this, we can just cancel out the denominators, x plus 2, and x plus 2, they just cancel out like that. And what is this going to give us? 15 divided by 6 minus x minus 2, because we have to distribute out the negative 1, right? So the answer for this one will just be 15th divided by 4 minus x. So these will be the answer for this one. Okay. Any questions for that, or is it clear? So for number 4, right, we're given a function, right, and we are asked to find the inverse for this. Like this. Let me move the entire thing down. There we go. And now let me move this down. Okay, there we go. So the inverse for this. So we can start off with calling our function y equals 3x plus 2 divided by x minus 1. We switch the variables now, or we can do this at the end, right? But right, we switch the variables. X equals to 3y plus 2 divided by y minus 1. Cross multiply, that will give us xy minus x equals to 3y plus 2. And we're solving for y, so we have to put them on the same side, right? So I can get xy minus 3y equals to x plus 2. If I move the y variables on the left side of the equation, and the x or any other terms that don't have a y on the right side of the equation. Factored out the y on the left side, right? And that will give us this. And finally, we can solve for y, and y is going to equal to x plus 2 divided by x minus 3. And this new y variable was originally x, right? So maybe the last thing that we can do is call this the inverse function, and that is equal to x plus 2 divided by x minus 3. Just to be clear that the answer that we have is representing the inverse of the original function, right? But in the exam question number 9 asked you something like this, but we couldn't do it because it's not one-to-one function, and that was my mistake for that one. So for number 5, let me see, move this out. There you go. So we are asked to, defining the function f of x, right, as a piecewise function, we are asked to sketch the graph of this function. And so I'm going to do this way. So here's the y-axis. Here's the x-axis. And so here is -1. So here will be 1. Here will be 2. Here will be 3, and so on, right? -2. So for the first part, right, the first segment, this is representing a straight line, right? It would have been like this, right? But we're going to cut off some of it. It would have been like this. Let's see. Maybe. It would have been like this, and it would have continued on like this, right? But what do we have to do to this segment? We have to cut everything to the right side of -1, because the first segment is only true for x values that are less than or equal to -1. So we're only going to select some piece like this one, starting at -1. Select this and going this way, like that. So we have to take the entire other pieces of the line away, and we're left with that. Mm-hmm.
So the negative x, this means that all of the x values are going to be negative?
Yeah, so negative x, the line y equals to -x, this is a line right here. What is the slope for this line? -1. And what is the y-intercept for this one? 0. Yeah. So if you think about this, what is a line that has a slope of -1 and has a y-intercept of 0? That will be the line that I drew, the entire line. But we only want the part of the line where x is less than or equal to -1. So that's these x values right here, these x values. Right? So we cut off the rest of the graph from the right side. Yeah. So now, for the second part, what kind of function do we have for the second part? A quadratic. And what will be the y-intercept of that quadratic formula? What will be the value when x is equal to 0? 2. So at x equals 0, we get a value of 2, like this one. What will be the value of the parabola at -1 when x equals -1? Positive 1. So it will pass through that point, right? So it will look like this. Do you see why is it facing down? Yeah, the -x². And say you want to know where the function is at x equals 1 and at x equals 2, for example. What is the value that we get when we plug in 1 into it? When we plug in 1, we're also going to get 1. Yeah, so we're going to get this one right here. So the graph will look like this so far. What is the value of, we should continue on, right? What is the value of this function at 2? -2. Yeah, so -1, negative 2. So at 2, we're supposed to pass through this point right here. This one. Do you see that that's how we're supposed to be, right? So we connect them, and the parabola will continue that way, like that. Nothing tells you that you should stop. On the contrary, right, the graph will continue on to the right side, on the left side. And if you want to label some points, you can label some points, but they didn't ask you to label anything, right? So if you think about this point right here, the x-intercept, for this one, right, you will have to use the second segment, set it equal to 0, and you're going to find that this is going to be the square root of 2, 0, but it's not necessary because they didn't say to label all intercepts, right? They didn't, so we wouldn't need to label them out. Yeah, but it's just the graph, the sketch of this guy. Right, so that is number 5. For number 6, you're given a function f of t equals to 3t minus 4 over t. They ask you to find the net change and the average rate of change from t equals to negative 1 to t equals to positive 2 for this function, right? So let's see. Let me go a little bit higher. Let's see. Right. So what is the net change? We define the net change like this, right? Net change. Ouch. We define this as f of b minus f of a, right? Where b is bigger than or equal to a. So these will be f of 2 minus f of negative 1. So f of 2 is just going to be, what is f of 2 going to be? Plug in 2 into that. So that's 6 minus, 4. So you see how we got 4, right? We just plug in 2 into our function. Minus, now plug in negative 1 in there. Negative 3 plus 4, right? Yeah. So that's going to be positive 1. And we subtract the 2 of them, we're just going to get 3. Again, how we got 4? Well, we just plug in 2 into our function. And how did we get 1? Well, we just plug in negative 1 into our function, right? Yeah.
So essentially, you can just do the absolute value of f of a.
We want to keep track of the negatives and positives, right? Because a negative will mean a drop.
But isn't it always positive?
Not always, yeah.
I thought you doing. Oh, so the b is the bigger of the input.
Inputs, yeah.
Not the output.
Not yeah. So f of b will be the value of the function at a later time, right? Or later x value or t value, and f of a will be the value of the function at the earlier t value. And you want to know whether you had a positive net change or a negative net change. Yeah. And what about the second part, right? The average rate of change. We abbreviated that with the right ARC for average rate of change. And this will be f of b minus f of a, over b minus a. So here we're going to have, right? So f of b minus f of a, we already saw that is going to give us 3, right? That's a net change on the numerator. And on the bottom, we're going to have 2 minus negative 1. So that will be 3 divided by 3. So all of these will just be 1. Just 1. Like that. So this is the average rate of change. Alright, so what about number 7? This is what we talked about yesterday. I gave you a chart, right? And I told you should memorize that chart. Uh-huh.
You have a negative average rate of change?
Yes. Uh-huh. So what will cause the negative will be the net change, right? On the bottom, it was always going to be positive all the time. Because it will be the b minus a, where b is bigger than a. So it's always going to be positive on the bottom, but if the net change is negative, then the average rate of change will be negative. Yeah. Mm-hmm. Yeah, but definitely we can have it negative. Yeah. And so later when we apply to functions like positions, right? Then these average rate of change will give you what we call an average velocity, right? Yeah. And if you apply this to a cost function, for example, you're going to get an average cost, right? And if you apply to like revenue, this will be an average revenue. You can apply it to real functions, and they will have different meanings. Yeah. So number 7, evaluate this expression, right? Sine of pi over 3 plus cosine of pi over 2 minus sine of pi over 3 times cosine of pi over 6. So let's see if we can fill this up, right? What will be sine of pi over 3? Square root of 3 over 2 plus cosine of pi over 2. Yeah, that will be 0. Minus sine of pi over 3. Sine of pi over 3 will be radical 3 over 2. Yeah. Times cosine of pi over 6, which is, yeah, radical 3 over 2. So we just have this. Radical 3 over 2 minus radical 3 times radical 3 will give us 3 over 4. And you can leave it like this if you want to. This is fine. You can't do anything or. Or you may try to combine them into 2 radical 3 minus 3 divided by 4 as a single fraction. But it's not required to combine this as a single fraction. Either one of these options is fine, right? Yeah. They're not like terms. You can't do anything more than that, right? Except maybe combining into a single fraction, but it doesn't help much. Right? But yeah.
So yesterday I solved the homework question relating to that. Like, let's say the whole thing is a square, you know what I'm saying? Like, I can really explain it to you. Like, I don't know if you understand or not. Let's say the whole thing is in a square. Like, what should you do? Like,
At the end, the answer, you square the answer.
12 minus 9 over 60. If we square the whole thing.
But if you square the whole thing, right? 2 square root of 3 minus 3 divided by 4, right? You have to multiply this by itself, right? So this will be 2 square root of 3 minus 3 over 4 times 2 square root of 3 minus 3 over 4. And you have to distribute things out.
Yeah, that's what I just said.
But you gave me an answer and that's not right. The answer you gave me is not right.
Yeah, it is. It's going to be 12 minus 9 over 16.
So on the bottom we are gonna have 16th, but on the top you still have to distribute things out like this. Yeah. You see, you have to distribute this times this times that, this times that, and this times that. You have to distribute things out.
We have to do that in the final.
Well, if they want you to square the answer, right, they will probably give you something that is easier to, yeah. But it's not a bad thing. Yeah. Do you see?
Or you can just, is it can be 12 minus 9
Mm-mm.
over 16?
No, if you say that, that's not right.
X squared of 3
Yeah.
minus 9.
Yeah, you're applying something like this. Look, you're applying a minus b squared. You're applying that this is a squared minus b squared, and I said doesn't know, right? Because this is not always true, but these will always be true. This is a minus b times a minus b, and when you distribute this out, you get a squared minus 2ab plus b squared. That's what these will be equal to. Not a squared minus b squared.
Yeah, just say long plus 6.
But do you see what you did over there? You did something like this where you squared.
I didn't do that. You don't have to, I did it in my own way.
Mhm.
Okay? I basically squared every single thing.
So you were saying that you're correct.
Based on what you just did.
Yeah. So if I squared all of the whole thing and is not correct, then what will you do? What will you say?
What?
If I do the problem and it doesn't come out to what you said,
And I will redo my homework.
yeah, but you're not taking notes, and that's not good. You're not, yeah. Right. So for number 8, find a coterminal angle between. So let me just cross this out, right? And cross this out, right? The answer is just in the middle. So find a coterminal angle between 0 and 2 pi for the angle theta equals to 17 pi over 3. So 17 pi over 3, it has, right? Let's see. 17 pi over 3. 2 pi, right? 2 pi is equivalent to
6 pi over 3.
yeah 6 pi over 3, and we wanted to have the same denominator, right, 3 as the original one. And how many 6 pi over 3 are going to be here?
2.
Yeah, so 6 pi over 3 plus 6 pi over 3. So far, this is going to make up what? 12 pi over 3 plus what will give me?
5.
Yeah, plus 5 pi over 3. But it's not enough, right? It's not enough to make another 6 pi over 3, right? It's not. So these 6 pi over 3 is 2 pi plus 2 pi plus 5 pi over 3. And what we're going to do is we're going to say that the 2 pi's are just representing going around the circle once, and then 2 pi again going around the circle again, and then plus 5 pi over 3. So the answer will just be 5 pi over 3. So if you're like wondering how this looks like, so we have a circle, but here, x and y, and you just went around the entire circle. You just went around the entire circle like this. So here's once, that's 2 pi. You did it again, that's another 2 pi, a total of 4 pi. And you still went 5 pi over 3. 5 pi over 3, what quadrant will you say 5 pi over 3 is on? So it cannot be in the first quadrant, cannot be in the second quadrant, it cannot be in the third quadrant. Yeah, it will lie in the fourth quadrant, right?
45 degree.
Like this, right here. No, not 45 degree. Yeah. So it will end up somewhere over here. Like this. Like that.
70 is 3 pi over
2. Yeah, 3 pi over 2. And if you compare that one with this one, this is going to be a little bit more. All you're missing is to complete another 2 pi, right?
You need one more pi over 3.
Yeah, you need another pi over 3. So pi over 3 is 60 degrees. Yeah. So what you will need is a little bit more, 60 degrees to make it over there. Yeah. Yeah. So what we said is why bother with all of this when you can just do this right here. Start in the positive x-axis and end it here. Why going around twice, right? When you don't need to do that, when you can just. So why will this be useful? Evaluating sine at 17 pi over 3 will be the same thing as evaluating any trigonometric function like sine at 5 pi over 3. They will have exactly the same value, right? Yeah. Right. So that is a review problems for 6.2. And let's talk a little bit about 6.3, trigonometric functions of angles, right? So this is 6.3. This is trigonometric functions of angles. And let's start off with this famous diagram that you guys have seen before. So we divide R2, right, the 2D space, or the XY plane, or we divide this into 4 quadrants, right? Here we're going to have the first quadrant. Here we're going to have the second quadrant. Here we're going to have the third quadrant. And here is the fourth quadrant. Right? And let's see. I'm going to draw a unit circle on the left side, just to determine the signs of all of these, right? Whether they're positive or negative and so on. So here's the unit circle. Right? And here's 1, 1. Remember that a point on the unit circle, say a point P, of coordinates x, y, we say that these one, the x component is representing what? The x component is representing the cosine value, right? And the y component is representing the
Sine.
So in the first quadrant, will sine be positive?
Yep.
Yeah, because sine is representing the y component of it, right? And in the first quadrant, any point there will have a positive y value and a positive x value. So over here in the first quadrant, we say that sine theta is positive, right? And cosine theta is positive because x is representing the cosine value and y is representing the sine value. if
Tangents also.
yeah, as a consequence, tangent is the sine over cosine, right? So that's also going to be positive as well. What about in the second quadrant? If you are on the second quadrant here, any point in the second quadrant, what will be negative there?
Sine.
Yeah, the x component will be negative, right?
I mean, the cosine.
So instead of being in the positive x-axis, now you are in the negative x-axis. So what is representing the x value? Cosine. So y still is positive, right? So we will say that here, sine theta will still be positive, but cosine theta is now, yeah. So what do you think about tangent theta?
Negative.
Yeah, because you're dividing sine over cosine, and sine is positive, but cosine is negative. So all of this will be negative, right? And what about in the third quadrant? Let's see. Ouch. In quadrant.
Negative, cosine is negative, tangent is positive.
So yeah. So in here we follow the same logic for this one. Yeah. So sine, you say sine is negative, right?
Cosine is negative,
Uh-huh.
tangent is positive.
There you go. And then this is positive. Yeah. Do you guys agree with that? Yeah, good. And you can always use the unit circle as a reference. Here's something to point out. When we say the first quadrant, we really mean everything where x and y are positive, not including the part of the x-axis or part of the y-axis. Just clean, just that section, right? We wouldn't include the x-axis or the y-axis. We wouldn't. For quadrant 2, again, we wouldn't include any of the axes. We use the clean space that is between the axes, not the axes themselves. And in the fourth quadrant,
Cosine is positive.
so we have sine there to be negative, cosine there to be positive, and tangent here to be negative. So you guys were told that the AS, right? What is it?
All students.
TC, yeah. Yeah, all students take calculus, right? It's required, right? Sometimes. So you know that in our school, if you're going to biology or business, you're not required to take calculus 1, 2, and 3. If you're going to biology or business, you can take an optional calculus sequence. We have 205 and 209. Those are meant for bio majors and business majors. So and again, later on when you go into economics or business, you will learn that maybe all the calculus that you learn in 205 and 209 weren't enough. So you are suggested before you go into a graduate program for business or to take calculus, right? 1, 2, and 3 before doing that. So, but it's enough to get a degree on biology and business. Whether you are going to do anything in science, right? You are required to take calculus, right? Students that didn't do so well in the placement exam, they did score really bad. They are told that they can retake the placement exam because they did so bad in it, right? And but the catch in that one is the system tells you can retake it only if you take a workshop, right? So they cannot just retake the placement exam whenever they want to. They will say you have to enroll in a workshop, and these workshops are going on along with this one, with this program. And there are other workshops that are going to start after this program ends. So when you have your days off, right, when the program ends on August 8th to August 27th, you guys are going to be relaxing. But there are other students who didn't pass the placement exam with any score, right, like a really, really low score. They're going to be here in school taking those workshops. They call them it's a Math 71 and Math 80 workshop. So Math 71 is to retake the placement exam. After they retake the placement exam, they are going to be giving a second workshop, Math 80, and this makes it very difficult for them to move on. And what happens with them is that they get really discouraged. When you talk to them, is like they're always in a bad mood, and you can understand them. Is like if they screw up really badly on the placement exam, they're told yes you can retake it, but only if you take the first workshop. You retake the placement exam, you get a score, you pass, then you go into a second workshop, saying that hey, before you move on, and they sometimes end up changing their major completely. When you talk to them, the ideas that they have to major in certain things, it changes. So they end up majoring in something that doesn't require any calculus at all, no calculus. So they go into a separate mathematics. Still, the college requires them to take a math class, so they take Math 150. Math 150 is one of the most boring classes, right? Because as an instructor, you can't make this interesting in any way. You can't. It's like you learn a little bit of everything, a little bit of probability, a little bit of statistics, a little bit of like algebra, a little bit of percentages, ratios, all of those topics that usually you wouldn't find interesting in a math class. So it's really hard for an instructor to engage students in that class. So and but the college requires you a certain level of mathematics is required. Do you know that as a architecture major, none of you here are in architecture, hopefully, right? But if you're an architecture major or you're going into architecture, you are not required to take any calculus. All you take is up to 195 pre-calculus. After you take pre-calculus as an architecture major, they will tell you that's it, you're done with your math classes, and then you get enrolled into architecture, and you will learn through projects and through assignments what you need to know, but they don't take any calculus whatsoever. It's not required. It's surprising. It's like that everything they need to learn it will be provided in the architecture, like the classes that they take for architecture. So but for engineering, physics, right, chemistry, for example, all of these, calculus will be required. It is because later in their classes, when they're using a formula, they need to know where the formula came from, like, right, and that requires some calculus behind it. So here, let's see if we can understand this, right? Here, this is a good question to ask. Find the value of sine theta, cosine theta, and tangent theta at theta equals to, let's put 2 pi over 3. So the first thing that we're going to do is identify which quadrant is 2 pi over 3 in. Right? That I think that's the hardest thing. Once we identify which quadrant it is on, everything will make sense. So here, so I draw the x and the y axis. Here is x and y. And what is the value of theta on the positive x-axis? The value of theta there, on the positive x-axis, theta is going to be 0. Yeah, on the positive y-axis there, theta is equal to pi over 2, 90 degrees. On the negative x-axis, on the other side, right, theta over there is pi. And then what about on the negative y? Yeah, 3 pi over 2. Right? Yeah, 3 pi over 2. Now, before we do anything like this, to identify which quadrant 2 pi over 3 is, you have an option. You can convert this to the degrees, but that's very unproductive, right? So what you can do is you can change all of this, right? You can change all of this to something that has a common denominator between 2 and 3. Common denominator. So theta equals to 2 pi over 3, what they gave you here. Right? You can write this so the denominator has a 6. And where do I get the 6? The denominator here is 2. The denominator there is 3. The common denominator will be 6. So what do you have in the numerator there? 4 pi over 6. Now, can you get these guys to have the same denominator as that one? Yeah. Sure. So this one will be something over 6. So that will be 3 pi over 6. The pi over here, theta equals pi, will be 6 pi over 6. And the last one on the bottom, right, will just be
18 pi.
Yeah. Yeah. So multiply this by 3, that will be 9 pi over 6. Now it is clear to see that 4 pi over 6 will be in the second quadrant. Do you see that if you take a look at this right here, right, and you take a look at these ones and these ones, you will see that 4 pi over 6 is between these guys. So which quadrant is it going to be on? Yeah, second quadrant. So once we figured out that this is in the second quadrant, So this is 4 pi over 6. Let me just do this. This angle that we found over here is theta equals to 4 pi over 6. And what do we know about sine, cosine, and tangent over there? That in the second quadrant,
Sine's positive.
yeah, second quadrant, sine will be positive, cosine will be negative, and tangent will be negative, right? So just keep that in mind, that we are expecting sine to be positive and the other ones to be negative. How do we find what sine and cosine is? What we take a look at will be a reference angle. Not the coterminal angle, but a reference angle. The reference angle will be what you need to complete all the way to the x-axis, right? You need to complete an angle to touch the x-axis, and in that case, it will be this little angle here, right? That little angle will be the angle that you need in order to complete right, to make it to the x-axis. 180 or 2 pi, right? Yeah, so it could be anywhere in the x-axis, right? So, this angle is always going to be a acute angle between 0 and 90 degrees all the time, right? So, let me just draw this smaller and call this a reference angle. And reference, what is that reference angle?
Give me pi over 3.
The reference angle will be the difference between pi and the angle that you have. But we are writing this angle pi as 6 pi over 6 to make life a little bit easier. Yeah? That's pi, right? 6 pi over 6. And what is the angle that we're given? 4 pi over 6. And it's easy to see that this is just going to give you,
2 pi over 6.
yeah,
Pi over 6.
yeah, which simplifies to, yeah. So this is 2 pi over 6 or just pi over 3. Now here's the catch. Let's start off with sine. Sine of 2 pi over 3. That's what we are asked to evaluate. This is exactly the same thing as sine of pi over 3. Why? Because in the first quadrant, all of them are positive. In the first quadrant, we said that here, they're all positive. Sine, cosine, tangent, they're all positive. In the second quadrant, will sine still be positive? So it's going to be equal to the value of its reference angle. So what is sine of pi over 3?
60, right?
Yeah, sine of 60. What is that? Radical 3
Radical 3 over 2.
over 2.
Over
Now,
2.
the second thing is cosine. Cosine of 2 pi over 3. This will be wrong. If I make this equal to cosine of pi over 3, this will be wrong. Why?
Make it negative.
Yeah, because cosine will be negative. So to fix this, I'm going to add a negative in front of that, right? And that will be true. That is good now. Why? Because on the left side, we are evaluating cosine of 2 pi over 3. That's cosine on the second quadrant. On the right side, we have cosine of pi over 3, and that's a reference angle. That's going to be in the first quadrant. Some angle between 0 and 90 degrees. They're not the same. Cosine in the first quadrant is positive. Cosine in the second quadrant is negative. So to fix that, we add a negative in front of it. And that's all we do. When we find a reference angle to evaluate sine or cosine or tangent, all we have to do is figure it out the sign, whether it's positive or negative. In this case, it's negative. So what are we going to get? Negative 1/2.
Mr. I have a question with you.
Uh-huh.
So why did you write pi as 6 pi over 6?
So that we wanted to know which quadrant this angle was in right here. Which quadrant is it going to be on?
2 pi over 3. It depends on what degree that is.
You one option would be, I said, to turn this into a degree, but that's not very productive. So what you do is you look at 2 pi over 3 and you look at the original angles that we have, this one and this one. The denominators for these ones are 2. The denominator for that one is 3. The common denominator will be 6. So you turn that angle 2 pi over 3 so that the denominator now is 6. And you turn these ones so that the denominator of these ones are 6.
But I think if we convert 2 pi over 3 into degree, then that will be much easier.
For you, yeah, sure. And you can do that. If you convert 2 pi over 3, that's 120 degrees. Clearly, it will be in the second quadrant. Yeah. But you have that option to convert it to degrees. Yeah, that's one of the options. Later on, it's not very productive to go back and forth degrees and radians. They give you degrees, just do it in degrees. They give you radians, just do it in radians. Is much convenient. Uh-huh.
So can you explain more about how we can get like those 3 pi over 6, 9 pi over 6?
How do we come with them?
Yeah.
Yeah. So is it clear why do I want to have this denominator here is 3? The denominators for these ones were 2.
So you need
So,
to have this here.
so I want to have a common denominator. So I convert this to pi over 3, so that the denominator is 6. And I do the same thing with this one. So I multiply this top and bottom by 3. So I'm going to have 3 pi over 6. I'm going to multiply this again by 3 over 3. That's going to give 9 pi over 6. And this one, I need a denominator of 6. So I'll multiply this by 6 pi over 6. Now if you focus on this one now, 3 pi over 6, 6 pi over 6, and 4 pi over 6 is clearly that since they have the same denominator, all you have to see is the numerators. 4 pi will be between 3 pi and 6 pi, so that puts it in the second quadrant. What will be the reference angle? The reference angle will be this little angle here. How much do you need in order to make it to the next angle, 6 pi over 6, or pi? Well, all you have to do is subtract the bigger one from this angle here, which is 4 pi over 6, and that's what we did here. So if it was in the third quadrant, then these will be the reference angle, right? And the bigger angle will be where the ray is, and you have to take away pi, or in this case 6 pi over 6, right? But in this case, it wasn't in the third quadrant, it was just in the second quadrant. If it was in the fourth quadrant, then this will be the reference angle. And you will need to subtract this, which is 2 pi, minus that big angle there.
So you wouldn't do 4 pi over 6 minus 3 pi over 6? The x-axis is always going to be the place where the reference angle starts from?
Yeah, always this guy here. So if you're here, the reference angle will be here. If it's here, the reference angle will be between this. If it's here like this, the reference angle is here. If it's here, then the reference angle will be equal to the angle itself, right? I'll draw that chart afterwards.
So if you're finding the sine of 2 pi over 3, why are you finding the sine of the reference?
Yeah, so sine of 2, the reference angle is this guy here, and the reference angle will always be an angle that is acute. So an acute angle will be an angle that is between 0 and pi over 2. So the reference angle will always be this one. So what we do is we are going to draw a reflection of this one here. And you can see that this is the reference angle. So will sine here, will it be positive or negative in the second quadrant? It's positive. What about in the first quadrant? Is it positive or negative? So that they will be equal to each other. But cosine, on the other hand, on the second quadrant here, cosine is negative. Well, the reference angle here is always going to be in the first quadrant. Right? What is cosine of pi over 3? Well, it's positive, because the reference angle pi over 3 is in the first quadrant. So to fix that, we are going to add a negative on it. So that's all we're going to do, add negatives or positives, depending on what the signs are. Yeah.
But I understand that, but the question asks is the sine of 2 pi over 3.
Mm-hmm.
Did you put equal to sine of pi over 3? Why did you put sine?
Sine is positive here and sine is positive here. Yeah, they're both positives. Yeah. When we do another problem, maybe we'll clear out a little bit more. Yeah. But if they're both positives, we just make them equal to each other. If here is negative, then we need to add a negative, right? And so on. Whenever we are in the second quadrant, cosine will be negative, so that's where we add the negative there.
So would you put a negative for the tan?
There we go. We'll put a negative. Why do we put a negative in tangent? Because tangent in the second quadrant will be negative, so we just add negative there. Yeah.
If theta was 240 degrees instead of 120 degrees, would we be subtracting that from 270 degrees?
360.
360.
Yeah, always from the x-axis. So the x-axis will be 360, right? And what you gave me is 240, will be somewhere over here, right? And the reference angle will be this piece right here, but not this one, right?
240 would be the third quadrant.
Oh, sorry, 200. So we'll have to subtract 180 degrees.
Now, like e power theta was 240 degrees.
Here.
If is in the third quadrant, then we would have to subtract it from 270 so that we can get a 30 degree angle.
No, but that will give me this angle here, which is not what I want. The reference angle will be here, always touching the x-axis.
The reference angle will be here.
Yeah, not on this side. Right here, what you gave me is 270 minus 240. But what the reference angle will be is 240 minus 180. The reference angle will always be in reference to the x-axis. Yeah, I will draw the diagram afterwards to say that if it's in the second quadrant, the reference angle will be here. So what do we do? We're going to do 180 degrees minus the angle that we have. 180 or pi, right? And if it's in the third quadrant, then we're going to do the angle that we're given minus pi or 180 degrees. Yeah.
So we never use 360, right?
Yeah, if it's in the fourth quadrant, like this, the reference angle will be this guy here, and this will be 360 degrees.
So if it's in the fourth quadrant, then we have to subtract it from 360.
Correct. Yeah. So we will never use pi over 2 or 270 degrees, 3 pi over 2. We'll always use either 360 degrees, 180 degrees, or even 0 degrees, right?
Then if it's in the second quadrant, then we have to subtract it from 180.
Yeah, correct. Yeah.
And if it's in the first quadrant, then we have to subtract it from 90 or 180.
From 0.
Zero.
Zero. Yeah, the same angle. If it's in the first quadrant, then the reference angle will equal to the angle itself. Yep. Yeah, so let's see. So now tangent of 2 pi over 3, that is tangent positive or negative? Negative in the second quadrant. So it will be negative tangent of pi over 3, right? Yeah. And what is tangent of pi over 3? Yeah, so it will be negative radical 3, right? There you go. So these will be the answers right here. This will be one of them. This is the second one. And here's the third answer. So we managed to evaluate all of them, right? Sine, cosine, and tangent. So let me draw you a little chart, right, that I mentioned. So here is what we have. So maybe 2. Yeah, that's fine. So here's x and y. And the idea would be that if you have an angle in the first quadrant, quadrant 1, and what we are going to do here is we are going to say that this will be the reference angle, right? Angle. And how we're going to get this, these will equal to the angle itself, right? The reference angle will be equal to the angle theta. Because if the angle is already in the first quadrant, then you don't need to do anything. That's already going to be the closest distance to the x-axis, right? So if the angle is here on the second quadrant, quadrant 2, if that's where the angle is, then where is the reference angle? The reference angle will be here. This will be the reference angle. And they won't equal to each other, right? That angle that I just gave you here, the reference angle will be theta. So 180 degrees pi minus theta, like that. Or if you want to think about it as 180 degrees minus the angle. Like that. That's how we're going to get it, right? Will it make sense why we have to subtract 180 minus the angle? The angle here is in the second quadrant. Right? Yeah. And what about something like this right here? Well, for this one, right, it's always subtracting something. So in other words, here to get this one, the biggest one will be the ray, the angle itself, and you have to subtract 180 from that. Yeah. So the reference angle here, reference angle, this is going to be theta minus pi, or theta or angle, whatever the angle is, minus 180 degrees, like that. So think about something in the third quadrant, like Kazi mentioned, 240 degrees in the third quadrant. Then 240 is this blue ray. You're going to subtract 180 from that, and what is that going to give you, like 60? So that is going to be the reference angle. The reference angle will always be positive, and it will always be between 0 and pi over 2 all the time. And what about this one over here, the fourth quadrant?
2 pi minus.
Yeah, so here is the reference angle. And this will equal to 2 pi minus the angle theta, or 360 degrees minus the angle, like that. So just to make it clear, this reference angle is always going to be between 0 and pi over 2. It could be 0 if the angle is 0 itself. It could be pi over 2 if the angle is pi over 2 itself, right? Yeah. So just keep those in mind. And we always say that because it's always bigger than or equal to 0, it's always positive, right? At least, or bigger than 0. So it's never negative. If you did the wrong subtraction, you end up with a negative, and that's not good. If you do the wrong subtraction, you're going to end something with bigger than 90 or less than 0. So that this is like important. The reference angle is not equal to the angle itself. They're not equal. They're not. The reference angle is a new angle. And so we don't call the reference angle theta anymore. The reference angle, the book uses this one right here. The book uses no reference angle. Our book calls it this, like theta with a bar on top. The bar on top is called a complement. Is like what do you need to in order to complete it to the x-axis, right? What that little missing part on it, yeah. And later on we apply this little top on these numbers, right? The complement of that, we apply this to complex numbers, and we call that the conjugate. The word conjugate that we heard earlier, that's the symbol that we use for it. We call it a conjugate, yeah, of a complex number. Question? No? Okay. So let's do another example, right? Let's see how this will work. Suppose that here's another example. Evaluate, right? Sine theta, cosine theta, and tangent theta at theta equals to 240 degrees. And I'm giving to you, theta is given to you in degrees now. So maybe it's a little bit easier to tell where things are. Right? So where is this angle going to be?
Third quadrant.
Third quadrant. Perfect. So here we have x, y. It's always the x, y axis that we draw there, the usual ones. And 240 degrees, in this case, will be here. This is quadrant number 3. And the angle that they just gave you here, this angle is this one right here. That's what they just gave you. That's theta. Theta in this case is equal to 240 degrees. These angles, and I always like to write them out, sometimes it's a waste of time, but this theta here is 0 degrees. This theta on top is going to be 90 degrees, right? Let me see. So sometimes it's like common, but maybe that's what we need to so this is 90 degrees, right? This theta here is 180 degrees, and this theta on the bottom is 270 degrees. So the reference angle in this case, according to the diagram that I gave you, to get the reference angle is going to be the angle minus 180. So this is how we're going to get this reference angle here. Reference angle. And what is that going to be? That's going to be, yeah, 240 minus 180, right? And what is that going to give me?
60.
Yeah, 60. Reference angle will equal to, I'm going to write it again. That's going to equal to 240 degrees minus 180 degrees. And that's just going to give me 60 degrees. Yeah, so let's see if sine and they're always the same exact thing. The signs will be the ones that change positive and negatives. So let's try to see what sine is. Sine, right, of 240 degrees will these be positive or negative?
Negative.
Because in the third quadrant, sine is negative, cosine is negative, but tangent is so sine will be negative sine of 60 degrees. That's why we don't, in the table that I give you, I never gave you 240 degrees, because we're going to use the reference angles, right, to figure them out. Right? So, and sine of 60 degrees, that is on the table. That is going to be the square root of 3,
Oh, it's sort of 3.
and then a negative in it. Right? So, what about cosine of 240 degrees? Will that be positive or negative? Negative. So, negative cosine of the reference angle. Yeah. And cosine of 60 degrees will be? Yeah. So, with a negative, right? Negative 1/2. And tangent, this is just a ratio between the two of them, right? This is sine over cosine, right? And what is that going to be?
3.
Yeah, just a square root of 3. So it's almost the same as the other one, except the signs change, right? Yeah. You're always going to be in the unit circle. So you're never going to leave. You're never going to get something like weird. It's always going to be one of these usual things. So, but these are the answers here. Let me just box this. There we go. Let's do a few more problems, and let's see if that makes sense. And then we're gonna take a break after that. So here is another example. Okay. Let theta be equal to 16 pi over 3. Evaluate sine of 16 pi over 3. Right, let me put theta, because that's what theta is, right? Sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. Like that. So all the 6 standard trigonometric functions, right? Right. So 16 pi over 3. Well, maybe the first thing will be to find the coterminal angle. The coterminal angle and the angle are equal to each other, because all you're doing is figuring out what the end position is, and you want to undo all of the wrapping that you go around it, right? So let's find the first thing will be the coterminal angle, right? So coterminal angle, and these will equal to theta. By the way, they're equal, not theta with a bar, just theta, because they are describing exactly the same end position, the same terminal ray. So the coterminal angle in this case, what is that? So we have 16 pi over 3, and the denominator here is 3. So 2 pi, right? One whole revolution, one whole going around the circle once, right? If you want to have a 3 on the bottom, you should have a 6 on the top. So 6 pi over 3. So 16 pi over 3 is going to be 6 pi over 3. That's 2 pi plus 6 pi over 3. That's 12 pi over 3. And then you still need 4 pi over 3. It's not enough to go around the circle completely again, right? So these will equal to 4 pi over 3. So on the back of your mind, you say the coterminal angle will describe exactly the same terminal, the same ending, right? So this is what we have so far. That 16 pi over 3, right, is equal to, 4 pi over 3. Because they have the same, right? Have the same terminal. And we call it point, terminal point. So the terminal point that I'm describing here is, if you have this right, xy, you went around this circle twice, right? So here is once. How much is that? 2 pi. Here's another one. How much is that? 4 pi. That's the 6 pi over 3. That's 2 pi. 6 pi over 3. That's another 2 pi. but you still have to add 4 pi over 3. 4 pi over 3, what is that going to be?
Quadrant.
In the third quadrant? Yep. So I agree with that, maybe.
Subtract a pi out of it.
Yeah. So this is what we're going to have right here. This is the terminal ray or the terminal point that this is describing. This is quadrant 3. But we are cutting all of this out by just leaving this out here. What is this angle here? That is what we just found. 4 pi over 3. So now we're going to start off with this right here. The coterminal angle is 4 pi over 3. Check. What do we need from this? We need the reference. Yeah, reference angle. Reference angle. And what is the reference angle going to be? Well, 4 pi over 3 ends up in the third quadrant. Yeah, so 4 pi over 3, we're going to subtract pi. So that's the same thing as 4 pi over 3 minus 3 pi over 3. Right? And that's just going to be pi over 3. That's the reference angle, right? Check. Good. Now, this is what we're going to do. Let's start up with one of them, right? Sine, for example. Sine of, they gave us 16 pi over 3. We're going to say that this is going to be the same thing as sine of, let's say these first, right? Sine of 16 pi over 3 is equal to sine of 4 pi over 3 because they are exactly the same, right? It's just going around the circle. But this sine in the third quadrant, is it positive or negative?
Negative.
Yeah. So it will be negative sine of, yeah. So, and then sine of pi over 3 will be radical 3 over. There we go. So we have the first one, sine. So the first two, you don't need to write the first two, the first equation and the second thing, but you definitely need to know that sine of 16 pi over 3 will be negative sine of pi over 3. Now let's do cosine, right? Cosine of 16 pi over 3, and you don't need to write this out, that this is equal to cosine of 4 pi over 3, right? But it's important that you understand why they're equal, right? And then the next thing is cosine in the third quadrant, is it positive or negative? So it would be negative cosine of its reference angle, which is pi over 3, so it would be negative 1/2. That's check. So we have two of them. Tangent should be just the ratio of them, right? So sine and cosine are the elementary ones. So tangent, 16 pi over 3, and that's just going to be, will it be, so it will be tangent, 4 pi over 3, I'm going to write this out like this. Will tangent there be positive or negative? Yeah, so this will just be tangent of pi over 3. And if you take a look at what tangent of pi over 3 was in the table, that's just radical 3. Which you could have figured it out by just taking the ratio of them, right? And that's easy. And so in the table, if you don't have enough space, right, in your memory to remember the entire table that we gave yesterday, what you can do is just remember the sine and cosine. And that's it. Right? Just sine and cosine. You can figure the rest out, right? Tangent is the ratio between sine and cosine. And then what about cosecant of 16 pi over 3? So this is going to be the same thing as cosecant of 4 pi over 3, right? Which is, and cosecant is the reciprocal of sine, right? Yeah. So that's just going to be negative 2 over the square root of 3, the reciprocal of that. And you don't have to rationalize it, but if you rationalize it, this will be 2 over 3, yeah, like that. Negative 2 radical 3 over 3. You don't have to, yeah. Not for unless they say rationalize your answer, then you have to rationalize your answer.
So like in the front of the test, it says you don't leave any exponents negative.
Yeah, then they will say it like that.
They say,
Yeah, in our exams, don't say rationalize your answer. Yeah, it's not a requirement unless that's what they want you to do, to rationalize it. Yeah, and before it turns out that calculators were like the Texas Instrument had issues with evaluating a lot of things, so they really wanted you to plug in certain ways so you can find the value of your answers. But now our calculators are smart enough to do this little. Yeah, yeah, but before they had a lot of so they will give you specific instructions. Make sure that your answer doesn't have any negative exponents because the calculator will have issues. Make sure the input is rationalized because otherwise the calculator will have issues. Because again, what the calculator does is approximates the values. And what does it do? Later on, you will discover that it uses numerical methods, and we can use power series to approximate values of radical 2, for example. Yeah, but then when you write it on the denominator and the calculator tries to do this, it's not very accurate. But if you rationalize it, all of a sudden the calculator understand. Back then, now the calculator can do this easily. Yeah, it's like before everything had to be done by hand. Now the machines are good enough to peel an orange, right? Cut apples, right? They are very precise on these things now. So what about secant of 16 pi over 3? That's going to be negative 2, right? So something that you should know is sine goes from negative 1 to 1, right? It never gives you something less than negative 1 or something bigger than positive 1 because it's the unit circle, right? The y value in the unit circle can never be more than 1, and the y value in the unit circle cannot be less than negative 1. But cosecant, the reciprocal of this, can give you anything as big as you want it to be, right? And secant, the same thing. So having a negative 2 there shouldn't be an issue for secant. It should be an issue for cosine, right? Imagine you put cosine of something equals negative 2, that will be wrong, right? So what about cotangent?
Be 1 over the square root of 3.
Mm-hmm. So in this case, it will be 1 over radical 3, or you can rationalize this as radical 3 over 3, yeah, like that. Yeah, but they're all correct. All right, let's take a 20-minute break. It is now 10:30. We're gonna come back at 10:50, and after 10:50, we're gonna evaluate all other things, and I will give you some tips on how to evaluate sine at negative angles, tangent at negative angles, and cosine at negative angles. Right. So I will see you guys.